So yesterday we completed this hexadecimal part. So we will start with data types. Okay. So if we have a 8-bit data, okay, if we have a 8-bit data or a 1 byte, so this lower side we will call it as least significant bit or last bit. Okay. So that is a LSB, and this at the end, like at the leftmost side, that this is the most significant bit, okay, or first bit, or we will also term it as MSB. Same with 16 bit uh, 16-bit characters or one word. This zeroth term will be our least significant bit or LSB, or and the this 15th term or this last left term, this will be most significant bit. Okay. Like if I tell you, if you have 1001 rupees, okay, if someone asks how much rupees do you have, then you will say it as 1000, because the most uh, has the most value. Okay, I have 1000 rupees, you won't say I have 1 rupees. So that's in also in this binary system, this leftmost bit will have the most value. So this is only written in this part. 1 byte data can be stored in each address of the memory space and microprocessor. So this is the definition. Within a byte, bits are numbered from zero. So zero is our least significant bit, and the seventh number is the most significant bit. Someone's mic is on. And for 16-bit words, Uh, 15th is the most significant bit and 0th will be the least significant bit. Okay. Any doubt in this? So earlier, whatever numbers we have seen, binary numbers, all those are unsigned binary bits. What is unsigned? It only contains positive number. Okay. But now we have to see a signed representation, means it contains both positive and a negative number. Like in binary, if we have a negative number, how we will represent that? Okay. We have only zeros and one in the binary number. So how we will represent a negative number in a binary form? So that is our unsigned and signed binary number. So what, like if I write a roll number, okay, you don't have to put any positive sign, because we know roll number will only start from 1 and it will continue and it is a positive number. So for roll number we are not putting any sign plus or minus. Okay, but if we have to represent a voltage, so voltage can be positive and voltage can be negative. So we have to represent it both as positive and negative. Like if 5 volts are there, we have to write plus 5 volts, and if minus 5 volts are there, we have to write minus 5 volts. Okay. So what is a roll number? Roll number is an unsigned representation. Like we don't have to put any positive or negative number before that. But like voltage, it has a positive and negative side, so that is a signed. Okay. So there are different types of signed binary numbers, but here we are using two's complement. You don't have to go in depth, but just you understand, like we are using this two complement. Like one complement is different, sign magnitude form is different. Okay, but here we are using two's complement. So what is a signed binary number? What we do in like we are only having 0 and 1. So what we do, uh, we take this MSB. Okay, most significant, what we do, we take this MSB and we assign a sign for this. Okay, we assign a sign for this. So we will take the most significant bit and we will say it is a sign. Okay, so what are the signs we are using? Because we are only having 0 and 1. So for MSB, we will indicate 1 as negative and 0 as positive. So we are taking 1 as negative term and 0 as positive term. Okay. So if we are having 8-bit binary number, what we will do, earlier unsigned binary numbers, we were taking all this number from 0, 1, 2, 3, 4, 5, 6, 0 to 7. All those numbers we were taking as magnitude. Okay, all these numbers as magnitude. But if we say it is a signed binary number, then this most significant bit we will take it as sign, and from 0 to 6 we will take it as magnitude. Okay, we will leave this last bit. So uh, for example, this is our binary number, 001 00101. Okay. So if we write it over here, so we are start from this least significant side, and we will write 2 to the power 0, 2 to the power 1, 2 to the power 3, up to 2 to the power 7. Okay. Then write the values of what is 2 to the power 0, 2 to the power 1, 2 to the power 2, like this. So what is this number? This number, if we add all this, so we will add 32 plus 4 plus 1. So what is 32 plus 4? What is the value 32 plus 4?
is 6.
And plus 1, it will become 37.
36.
Okay. So this will become a 37 number. Okay. So it is not given whether it is signed or it is unsigned. So it is signed, it is unsigned means we will assume it is a positive number. Okay. So, but what if we add a 1 in the end? So, as we can see, it is a unsigned binary number. So, we won't change this to sign, but we will take this value. Okay. So, what our output was coming? It was coming 137. So, here 128 is also there. So, we will add 128 plus 37. All these values are 37. So, what will be the total value? It will come as 165. Okay. So for unsigned binary number, we are getting a 165 for this binary number. Okay. 101000101. But what if we make this number as a signed binary number? What if we make it as signed binary number? Okay. So if we say this binary number is a signed binary number, so we will write this binary number here, but the last 2 to the power 7th part, it will become a sign, symbol of sign. Okay. So for this binary number 001000101, so here we have a 0. So what does that 0 means? It means it is a positive term. Okay. So it is a positive term, so we will write it as plus 37. And if we have a binary number 101000101, so we will write in this form. One minute. So we will write in this form, this form, and we will write from 2 to the power to 2 to the power 6. We will leave 2 to the power 7, the most significant bit, and we will write it as sign. Okay. So what is this sign? So here we will leave this magnitude, and we will see we have a 1. So what does 1 mean? It means it is a negative. So we will write a negative 37. Okay, same way with 45. And you can say one more difference, one more similarity. You see this plus 37 and this minus 37. You can see from 0 to 6 term, all the digits are same. Okay, but this last bit is changing because it is a sign, and this is a plus positive number, and this is a negative number. So that's why it is changing from 0 to 1. Otherwise, all the other elements from 0 to 6th element, all are same. So this is actually 2's complement. For 2's complement, this more significant, only this will change, others will be same. or this 2 complement. That's why we are using this 2's complement. Okay. Similarly, for plus 45, you can say like we are representing as 1 0 0 1 0 1 1 0 1. Okay. But for minus 45, these things will be same. Only because it is a minus, we will put a negative sign in the most significant bit. And what is a negative sign? It is a 1. So we are putting a 1. For the signed and unsigned binary number, if you have a signed binary number, means you have a positive and negative, it will be mentioned that it is a signed binary number. You won't be simply given like you will be given any number and you have to guess whether it is signed or unsigned. It is not like that. If it is a signed binary number, it will be given like it is a signed binary number. Okay. Signed means either it has a positive or it has a negative. Any doubt in this part? Any doubt? Should I explain it once more?
Yes, ma'am.
Yes, ma'am, I couldn't
Yes,
understand
ma'am.
it properly.
Okay. Like any numbers you are having, so for one element, one bit you won't have anything. But what if we have two bits? Okay. So one is most significant bit and one is least significant bit. So the lower side, it will always be least significant bit. Okay. So for 2 bit, this will be our least significant bit and this will be a most significant bit. The last left side term, okay, the leftmost will be most significant bit and the rightmost will be least significant bit. For 2 bit, this will be least significant and this will be most significant. Okay. Similarly, for 3 bit, this rightmost will be least significant and this leftmost will be most significant.
So, ma'am, basically the thing on the left is the most significant.
Yes, like if I'm saying now, if you are a millionaire, okay, but you have like 1 million and something two like 2,300 like something. But what I will say, you are a millionaire person, okay, you are a millionaire like that. We won't say na you have this thousand something rupees like that. We won't say that. So what is the most significant? Most significant, like you have 1 million in your bank account. So that is becoming more significant. Like you are a millionaire, you are a billionaire. We won't say what is the total value of Bill Gates. We just say that he is a billionaire type. Okay. So what is the leftmost value is the most significant. That's why we are saying it is a most significant. Any doubt?
No, ma'am.
Hmm. So for 4 bit, this 2 to the power 0, it will be least significant, and 2 to the power 3 term, this will be most significant. So similarly, here they have mentioned for 8 bit. Okay. For 8 bit, we are starting with 0th term. Now we are not starting like first term. We are starting with 0th term. So we are saying this 0th term or the rightmost part is the least significant bit. And the leftmost part or this seventh term is the most significant bit. Okay. So that's why we are saying this as least significant and most significant. Similarly, for 16-bit numbers, this 0th term will be least significant bit and this 15th term will be most significant bit. So we represent it as LSB and this leftmost part we represent as MSB. So this is only what is mentioned over here. 1 byte of data can be stored at each address of memory space in a microprocessor. So this is a definition for book. Leave it this for now. So within a byte, bit are numbered 0 is least significant bit to 7, which is the most significant bit. And for 16-bit word, 15th is the MSB and the 0th will be the LSB. Okay, any doubt in this most significant bit and least significant bit?
No, ma'am.
So whatever we studied earlier, it is actually an unsigned representation. Okay, I will just give a roll, like your roll number or something in your bank account. Okay, it can never be negative. It can be zero, but it can never be negative, like amount in your bank account. So what we can say, it is an unsigned binary number. Okay, like no sign is there, but like your raw number, you will always know it is a positive. It will always be a positive, like from it will start from 0 to 1. So no need to write a positive in front of your roll number. We know that it is a positive term. But what if our number is becoming negative? So in binary we have both positive and negative. So how we will represent this positive side and negative side in a binary number? We have to only use the 0 and 1. So how we will write this negative number in a binary form? So if we have to write a negative number in a binary form, that is called a signed binary
Ma'am,
number.
excuse me, ma'am.
Yes.
Ma'am, the portions that you are teaching now, are there, is this there in the syllabus?
Yes, signed and unsigned is there, but this table is not there. I have put this table for explanation.
Okay, ma'am. Thank you.
So, but signed and unsigned is there, but this table is not there. Just for explaining, I am telling you. Okay. So, what is unsigned? Only positive numbers are there. But if we have both positive and negative numbers, then you have a signed, we will call it as a signed binary number or signed representation. So here in the syllabus, we are using 2's complement. The signed binary numbers are also of different types, but we have to study this 2's complement. Like you don't have to study this 2's complement. Just whatever we are using, these are type of 2's complement. Okay. So that is written in the book. So in the book, it is written negative sign numbers are represented using 2's complement notation. Only this part is only mentioned in your book. Okay. If it is a signed binary number, it will be written like it is a signed binary number. It won't be written like you are given a number and you don't have to guess whether it is signed or unsigned. If it is a signed binary number, it would be mentioned there that it is a signed binary number. Okay, because no other notation is there, no positive and negative sign is there. Okay, so how we will represent this signed binary number? We will take this most significant bit. Okay, we will take this most significant bit and we will assign a sign for this. So for most significant bit, if our logic is this bit is 1, then it is a negative. But if our bit is 0, then it means it is a positive. Okay. So for any other number, any unsigned binary number, if I give an example of this unsigned binary number, so we will write this unsigned binary number and we will evaluate what is the, if we convert it to decimal, what it will be. So we will write 001000101. Okay. So how we will convert this to decimal? We will put a 2 to the power 0, 2 to the power 1, 2 to the power 2, up to 2 to the power 7. Then we will write the value for this 1, 2, 4, 8, 16, 32, 64, and 128. Then we will see this, what is the value. Okay. So we will add this 32 plus, because 1 is there, here 1 is there, and here 1 is there. So we will add 32 plus 4 plus 1. Okay. So that will become as 37. So we will know this value is 37. But if another binary number, unsigned binary number, it is given as 101000101. So we will write this. So all these are same. So it will be 37, but we have added a 1 instead of a 0. So we have to also add 128. So 37 plus 128, it will become as 165. So the value of this unsigned binary number, it is coming as 165. Anyone has a doubt in this?
Ma'am, could you explain the last part again? I couldn't understand it.
37 you understood? This 37, how we are getting 37?
No, ma'am.
So how we are converting this binary to decimal? Okay. So if this binary number is given 0110 0100, so how we are converting it to decimal? We are starting from this least significant bit and we are writing 2 to the power 0, 2 to the power 1, 2 to the power 2 up to the end. Like we are increasing 1 each. This you remember, na?
Yes, ma'am.
So we will write the value of this 2 to the power 0 as 1, 2 to the power 2 as 2, 2 to the power 2 as 4, like this, 2 to the power 7 as 128. Then what we are doing, we are adding whatever is below this. Okay. So 64 into 1 will be 64 plus 32 into 1 will be 32. Then 4 into 1 will be 4. So what we will do, we will add 64 plus 32 plus 4. So what is 64 plus 32? It is, what is 64 plus 32?
96.
And 96 plus 4?
100.
Hmm. So what is the value of this binary number? It is 100 in decimal. Okay. Any doubt how we are converting this?
No, ma'am.
Hmm. So similarly, so that is an unsigned binary number. Whatever we are doing here, this is an unsigned binary number because no sign is given over here. Okay. So what if we are saying that if we have a negative number, so how we will represent a negative number? Okay. So what we will do, we will take this most significant bit. So for unsigned binary number, all these values are magnitude. Okay, from 0 to the 7th term, everything is. He is asking that can I share the IIT papers? So actually, the syllabus has totally changed. Earlier, you have to study this PN junction and all, but this time the syllabus is new, so new questions will come. This time, the syllabus is actually the applications of basic electronics and communication. Earlier, it was basic electronics. So we had to study this PN junction, Zener diode, how diode is working, how transistor is working. But it is of no use to students of other branches. So what they are doing, they are just telling us the application of how electronic devices are working or how communication is working. So I told you for this part. mm, For this part, data representation and data type, this conversion type will come. Like convert hexadecimal to binary, binary to hexadecimal, or binary to decimal and decimal to binary. Only this will come. Mostly hexadecimal to decimal will come. So yeah, so what if we have a negative term? Okay, how we will represent in a binary form? So in binary, we know only we are having 0 and 1. Okay, so how we will represent this 0 and 1? Okay, so like if we have a plus 37 and a minus 37, so how we will represent this plus 37 and this minus 37? So what we do now, we take this most significant bit, uh, we take this most significant bit and we assign it as a sign. This is as a sign, like it will represent whether a number is a positive and a negative or a negative. Okay, So if this number is there 101000101, and if we say it is an unsigned binary number, means unsigned binary number means it is only a positive number. Okay, no sign is there. So then what we do, we start from 2 to the power, we will write this number, the this number, this binary number, and we will start assigning 2 to the power 0, 2 to the power 1, means how we will convert this to decimal. So we will start doing 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Okay, and as it is an unsigned binary number, so this most significant bit, it will also represent a magnitude. Magnitude means it has a value. You might have studied in vector. Vector has a magnitude and a direction. Magnitude means what? It has a value. Okay. But if we say it is a signed binary number, then this most significant bit, it will not be a magnitude. It will represent it as a sign. So from 0 to the sixth term, it will represent a magnitude, but this last bit, this most significant bit, it will represent it as a sign. So for if the sign is 0, we will say that it is a positive term. And if the sign is 1, if the value is 1, then we will say it is a negative number. Any doubt?
No, ma'am.
Okay. So understood the difference between signed and unsigned?
Yes, ma'am.
Hmm. So, uh, like if unsigned binary number is there, it won't be written anything like it is an unsigned binary number. You have to assume this is an unsigned, means only positive numbers are there. There is no negative number. So this most significant bit, you have to take it as magnitude and not the sign. Okay. So what will be the value of this unsigned binary number? Okay, so for this binary number 00100101, how we will convert this to this decimal number? So we will start writing from this least significant bit. We will start writing 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7. Because it is an unsigned binary number or a positive number, so to this 2 to the power 7, it won't be a sign. Okay, it will have a value of 128. So if we add all these numbers, okay, so what is the value for so here we can see we have to do multiplication of 1 into 32. So all others are 0, so it will be 0. So where we are getting a 1, we are getting a 1 at 32, 4 and 1. So if we add 32, 4 plus 1 while converting from binary number to decimal, so what is the total value? It is 37. Okay. Any doubt in this conversion?
No, ma'am, I understood it.
Understood the whole topic?
Ma'am, still for
Okay. So here instead of 0, if we put a 1, okay, and it is an unsigned binary number, it means it will have a magnitude. So all others are same. You can see all others are same. This last part is only different. So this is 37. So total is 37 plus 128. So what will be the total? It will be 165. But what if we say these two numbers are signed binary numbers? Okay. So this from 0 to the sixth term, we will have a magnitude. So we will write 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. But this most significant bit or the seventh number, we will assign it as sign. Okay. So we will assign it as a sign and we won't use this for addition. So if we add this same number and we say it is a sign, then we will add this 32 plus 4 plus 1. So it is coming as 37. Okay. And we will see the sign. What is the sign? Sign is 0. So what does 0 means? It is a positive. So we will write it as plus 37. Okay. We have to add this plus because it is a signed binary number, so we have to add a plus. And the same number, what if we write it as sign? So here we will start writing from 2 to the power 0 to 2 to the power 6, and last is this sign. So we will only use this 0 to 6 term as magnitude and last as sign. Okay. So if we add this, then it is coming as 37. And this most significant bit is 1. So what is 1? It is a negative. So what will be the value? It will be minus 37. Okay. So if we see this value of plus 37 and minus 37, so minus 37 is written in the form of 2's complement. So if we see both these numbers from 0 to 6 number, we can say all these things are similar. 0, 1, 0, 0, 1, 0, 1, all these magnitudes are similar. Only because of the sign, this most significant bit, it is changing. Plus 37, it is becoming plus 37, it is 0, and for minus 37 it has a 1. If you say this 45 and minus 45, for 45 we have this number and the last most significant bit is 0, and for minus 45 this most significant bit is 1. Okay, any doubt in this?
Yes, ma'am. Ma'am, is there any assignment out here for this?
Yeah, I will give you an assignment in the second part. Today I thought I will start the logic gates and give an assignment on that, but I don't think I will start logic gates today.
Ma'am, you posted 4 assignments in the Google Classroom.
Ah, yes.
Ma'am, do we need to do that?
Not right now. The J section, na?
Yes, ma'am, J section. You posted 4 assignments, and then there was no due date on it, so I had to ask.
Um, where is the assignment? Sorry.
But ma'am, this is question bank, and there is one for assignment.
Which one?
This is question bank, na? You gave 4 other assignments.
So after I complete this module, then only I will give the assignments. If I started this logic gates, then thought of giving an assignment on this logic gates. You have to make a binary all the gates, but as I have not started, so I won't give.
Okay,
Actually, this
ma'am.
assignment questions also, these are little bit wrong. I have not made this. Some other faculty has made this assignment. So actually, something wrong is there.
Okay, ma'am. So you do not have to do that assignment, right?
No, not right now. At the end of next week, I will give you the assignment.
Okay, ma'am.
See, in this conversion part, he has given binary to octal, so this is wrong. So this we have to discuss what we have to change in this. And here
Okay, ma'am.
you have not studied this point values now, so you don't need this 0.15. So you don't have to do this. That's why this has to change. So I was thinking of discussing about this and giving in your at the end of the week.
Okay, ma'am.
Any other doubt is there? I will start with a new topic in the next class, otherwise you will again get confused. I had to start with logic gates, but I'll start it next. So here I think you will get one question like this. So what is a from actually we have not got any model question paper from the VTU. So if we get a model question paper, I think questions will come from there only. So we have made our own question paper. So this is one question you will get. What is a bit, byte, nibble, and word? And I think this is a previous question paper. It is from previous question paper. So we are not studying octal. This 8 is octal. So this question is totally wrong. That's why I'm not giving you any assignment. And I wanted to teach you
Okay,
the
ma'am.
logic gates. So this one question will come. And for logic gates, I wanted you to make the circuits in Logisim. So that was one assignment for you. But as I have not started logic gates, so no need to give any assignment. All these assignments I will give you by the end of the week, next week. Okay. Those who don't have any doubt, they can write your roll numbers and leave. New topic I will start in next class.
Okay, ma'am.
Ma'am, do you have handwritten notes for these topics?
Sir is writing one notes. I made it for module 3. So, like everything I'm trying to put in the PPT only. So that is enough. But we will give you a handwritten note after he completes the notes.
Okay, ma'am. Thank you.
All the notes I am giving you, write it in your copy. That will become a handwritten note.
Yes, ma'am.
If anyone has any doubt, they can stay and ask the doubt.
No.
Ma'am,
Ma'am,
can we
can you
leave?
send the
Ah, yes, you can leave.
excuse me, ma'am?
Yes.
Can you send the link for joining the Google Classroom? I have not joined. Ma'am,
Yes, I'm sending.
can you send the link for Aryan Barnwal?
Should I
In
send
the
it
group,
here?
can you send, ma'am? Or in the
Hmm.
group, can you send, ma'am? In the group. I haven't joined yet. Or here also it's fine, ma'am.
Okay, sending. I am sending it here. Okay.
Okay, ma'am.
Any other doubt?